Okay, this is lesson 37 that we didn't get a chance to go over in class. Before I start, I want to remind you that we will be having a notebook check in class on this coming Tuesday, October 6th. So please be sure that you have your notebook set up with the dividers for notes, assignments, tests, and quizzes, and that you have all your stuff in there and in order so that I can go through and check them really quickly. That will be an important part of your participation grade, so please make sure that you have it all set up and ready. All right, lesson 37, I just want to start out by going over the distance formula again. When you have 2 points and you want to know the distance between the 2 points, you can just set up the Pythagorean theorem to figure that out. The distance between 2 points is a straight line, and when you have a point like x1, y1, and you're trying to find the distance to x2, y2, you just draw a right triangle. The horizontal leg is just the difference between your x coordinates because you're going from x1 to x2 horizontally, and then vertically, your vertical leg is your just difference between your y coordinates because you're going from y1 to y2. How far is that? Well, it's the difference between the y coordinates. All right, so setting up the Pythagorean theorem for this triangle, you would have d squared equals, sorry about that, d squared equals the difference between the x's squared plus the difference between the y's squared. So this is just the Pythagorean theorem for this triangle right here. And so to solve for d, you're just going to take the square root on both sides. So d would equal the square root of the difference in the x's squared plus the difference in the y's squared. And just one hint that it doesn't really matter here in these parentheses whether you put x2 minus x1 or x1 minus x2. You're squaring it, so it's going to be the same no matter what. So you don't have to worry about whether you're putting the wrong thing first or anything like that. So that's the distance formula, and that helps you to find the distance between any 2 points. So if I had 2 specific points here, let's say that I have -2, -3. Well, that's not going to work. We're going to have to redraw it. So if I have 2 points, -2, -3, right here, and I want to find the distance from that point to the point 4, 2. Then what I'm going to do is I'm going to draw the right triangle straight down and then straight across. And so the horizontal leg is the difference between the x's, so from -2 to 4. So -2 minus 4 is going to be 6 for that leg. And the horizontal distance is from -3 to 2. That's going to be 5 spaces up to there. So we know that 5 squared plus 6 squared is going to equal d squared. All right, so that's what we're doing when we write out the distance formula. But I'm going to go ahead and write it out. The distance between the 2 points is equal to the square root of the difference in the x's, so -2 minus 4 squared plus, good grief, Sorry, my pen is being a real pain. So plus negative 3 minus 2 squared, the difference in the y's. So that is the square root of negative 6 squared, which is 36, plus negative 3 minus 2 squared, which is negative 5 squared, which is 25. So that is going to give me the square root of 61. So that would be the answer for the distance between those 2 points. So the distance formula is a formula that you need to know, but you don't have to memorize it. You just need to know what it means. It just means the Pythagorean theorem. D is the hypotenuse, and then the other 2 legs are the differences in the x's and the difference in the y's. So if you just plug all that into the Pythagorean theorem, then it will all make sense. Okay, now we're going to talk about the definition of a line as a locus of points. And it's just another way of talking about a line. So far we've talked about a line as, we've usually just found the slope and the y-intercept and talked about the line that way. Now we're going to talk about a line as a locus of all points in a plane that are equidistant from 2 specified points. And what that means is it's just a locus just means a location or a group of points that are equidistant from 2 other points. Here's a picture of that. We've got a line here, and we've got 2 points, A and B, and we're saying that any point on the line is going to be the same distance from A as it is from B. So this point right here is x away from A, and it's x away from B. This point on my line might be y away from A and y away from B. Doesn't matter what the distance is. I'm just saying that for any point on this line, if you draw a point to this point A and you draw a point to this other point B, these 2 lengths are equal. So when we talk about finding the equation of a line that's equidistant from 2 points, we are just going to use the distance formula to help us do that. So if I wanted to find the equation of a line that's equidistant from the points 4, 2 and negative 2, negative 3, and I want to write it in slope-intercept form, then what I'm going to have to do is set up an equation to show that every point xy on my line that I'm getting ready to write the equation of is the same distance from 4, 2 as it is from negative 2, negative 3. And to do that, I'm going to use the distance formula. So first I'm going to talk about the distance from any point on my line to the point 4, 2. The distance from any point on my line, xy, to the point 4, 2 would be written using the distance formula as x minus 4 squared plus y minus 2 squared. Okay, that's the distance. The square root of x minus 4 quantity squared plus y minus 2 quantity squared is the distance between the point 4, 2 and any point on my line. All right, and what I want to say is that that is the same as the distance from any point on my line to negative 2, negative 3. That's what I'm trying to say here. I'm saying all the points on my line have the same distance from themselves to 4, 2 as to negative 2, negative 3. So the distance from my point on my line to negative 2, negative 3, using the distance formula, is just x minus negative 2, which ends up being x plus 2, quantity squared, plus the distance, the change difference in the y's, so y minus negative 3, so that's plus 3, quantity squared. Okay, so this is how I'm going to write my equation of my line. I'm just setting up a situation, an equation that says the distance from xy to 4, 2 is the same as the distance from xy to negative 2, negative 3. Because that's what I'm trying to do here. I'm writing the equation of a line that is equidistant from those 2 points, where every point on the line is equidistant from 4, 2 and -2, -3. So now all I have to do is just deal with this mess and get it into slope-intercept form. And so what I'm going to have to do first is square both sides to make the square root signs go away. So I'll just have x minus 4 quantity squared plus y minus 2 quantity squared equals x plus 2 quantity squared plus y plus 3 quantity squared. And you don't know how angry I'm feeling towards this pen right now. I just really want to throw it across the room. Okay, so we're going to square this out, so that x minus 4 quantity squared is x squared minus 8x plus 16. And we're going to do the other one. Y minus 2 quantity squared is y squared minus 4y plus 4. And that is equal to x plus 2 quantity squared, which is x squared plus 4x plus 4 plus y plus 3 quantity squared, which is y squared plus 6y plus 9. Okay, so we've got all this stuff, and fortunately some of it cancels out. There's an x squared on both sides, we can get rid of that. There's a y squared on both sides, we can get rid of that. And now we can just combine like terms. So we've got a 4x over here, and we've got a negative 8x over here. So I'm going to add 8x to both sides. To get all my x's over there. So these are going to cancel. And over here I'm going to have 12x. My equal sign there. And then I've got negative 4y over here and positive 6y over here. Well, actually, I want to get all my y's on the left side because I want to get this into the slope-intercept form, which is y equals mx plus b. So I'm going to subtract 6y on both sides. So over here, I'm going to have negative 10y. So those are now canceled out. Well, that doesn't really cancel, but hang on. Okay. So yeah, that's negative 10y over here and then over here. Okay. So these cancel. Right. Okay, and then I've got 16 and 4 on the left side, which is 20, and I've got 4 and 9 on the right side, which is 13. So that I'm going to subtract 20 on both sides. So 13 minus 20 is negative 7. Is that right? 13 minus 20 is negative 7. And then I'm going to divide by negative 10. So y equals negative 12/10 x plus 7/10. And of course you would want to reduce that fraction. So it would be y equals negative 6/5 x plus 7/10. So now it's in the slope-intercept form, which is what I wanted. Right. Okay. So that is how you find the slope-intercept form, or the equation of a line, that is equidistant from 2 points. So these 2 points right here are not on the line. They are equidistant from the line. So any point on the line will be the same distance from 4, 2 as it is from -2, -3. And you set up that equation, solve it, get it all into the form that you asked for, and you're good to go. Okay, so the last thing in lesson 37 is the midpoint formula, and this is just how to find the point that is exactly in the middle of 2 other points. And this is very simple. All you have to do is take the average of the x's and the average of the y's. So the formula will look like, if you want to find the point that is halfway between x1, y1, and x2, y2, then all you have to do is take the average of the x's and the average of the y's. So what that means is x1 plus x2 over 2, y1 plus y2 over 2. So that's it. That's the midpoint formula. So if you're trying to find the coordinates of the midpoint, all right, let me just make this thing stop being so terrible. All right, so say you want to find the coordinates of the point halfway between -2, 6, and 4, 10. Then all you have to do is set up this average of the x's, average of the y's. So for the x's, you've got -2, 4. You got -2 and 4 is what I meant, divided by 2. And then for your y's, you've got 6 and -10. Over 2. So average of your x's, average of your y's, that gives you 2 over 2, which is 1. And -4 over 2, which is -2. So that is the point that is midway between -2, 6 and 4, -10. That is the midpoint formula. And anytime you want to find the midpoint between 2 points, you just take the average of the x's, the average of the y's. And that is lesson 37.